Okay, so here's an example of a quadratic inequality in two variables. And again, we're talking about solution regions, right? Oh, I'm going to get rid of this. And so we're talking about in two variables, we want to be shading part of the Cartesian plane or the coordinate plane. So the first step has always been, even in 9.1 when we talked about straight lines, is to try to graph the borderline, okay? Try and graph this y equals -2 x minus 3 squared plus 1, okay? Try and graph that. Okay, well, let's see. What do we know? This is the vertex form for a parabola, right? So I know that my vertex is the opposite sign, this number, so +3, the same sign, this number, +3, +1. That's my vertex. So I'm going to plot that 1, 2, 3, and then up 1. There's my vertex. Now I know that this is opening downward because A is negative, right? That's A, and it's a -2, okay? A -2. So if I go, now you remember how you quickly graph a parabola using the A value. You can make two other points real quick, and you can go to the left 1 unit, and then either up or down according to what this A value is. So you could go over 1 unit, left and right, and then go down 2 units to get your next point. So over 1, down 1, 2. If this is at -1. So you know that that's on the parabola. And I could do the same thing, go over 1, and I could go down 1, 2. See that? So that's how that works with the A, and you could quickly graph that. Now, the exact x-intercepts, okay, we could go ahead and solve that, but you know what, we're just going to do a fairly careful sketch here. So from this vertex, I'm going to try and connect through this point with a parabola. It's going to be pretty narrow. Oops, I got to be a little more careful with my point there. So that's what my parabola looks like. It opens down. And all right, so this is good enough for now. And what I need to do now is I need to graph the inequality. So now I've graphed the line. I have to go back and now look at the inequality. And what I realize is, the first thing that I realize is this is not an or equal to. It's just a less than. So guess what? My borderline actually has to be dashed. No problem. If you have a pencil, you could just erase some lines out of there. Unfortunately, I can't do that, so I'm going to have to redraw mine. But you make a dashed borderline because there's no or equal to. So that means that the points on this parabola are not part of the solution set or the solution region, right? So it's got to be dashed because there's no equal there. Okay. So let's go back to this. Now what I want to do is I want to see, I want to test a point. And again, 0, 0, I always suggest that you test 0, 0 because it's an easy one to evaluate. So let's test the point 0, 0 and see if it makes this inequality true. So it's going to have to be a less than. So y is 0, and then x has got to be 0 over here too. So this is what I mean. Plug in 0 for x and 0 for y. That's the point 0, 0. And I want to see if this solution region, kind of above the parabola, if that is part of the solution. So does 0, 0 make this true? Well, what do we have over here on this side? I have -3 squared is +9 times -2 is -18 plus 1 is -17. Okay, so is that a true statement? Is 0 less than -17? You would say no. So if this is a no, then guess what? This point is a no. Therefore, the solution region would be on the other side of the parabola border, and it would be sort of inside the parabola looking like this. And that's how you would graph your solution region. All right, so what you can do as well, because it's always good to double check and to test the affirmative. So let's try and pick a point that we know is in here, and let's just make sure that we didn't do something wrong with our algebra here. Because if you get something wrong over here, it's good to double check to make sure. So 3, 1 is the vertex. Let's go 3, let's say -1. Let's try 3, -1, okay? 3, -1 should be underneath this parabola in the solution region. So let's just check that out. So -1 is going to be the y value. And if I have now 3 here, let's see. So I have -1 is less than, well, this is 0, so this whole thing is 0 plus 1. So -1 is less than +1. Is that true? Yes, that is true. So this is in the solution region, so we've confirmed that we're correct. Okay? Now determine if the point 2, -4 is a solution. Okay, I could have tested that one too, I guess, but I don't know if that's in the region, so it's not a good one to test for your affirmative, right? But let's test it now. 2, -4. I'll use, let's see, black color again. So -4 is my y. I'll put that there in for y. And I'll plug in +2 in for x. So 2 minus 3 squared plus 1. -4 here. Whoops. So let's just see. 2 minus 3 is -1 squared is +1 times -2 is -2 plus 1 is -1. -2 plus 1. So is -4 less than -1? That appears to be true. It's further to the left on the number line. So, oh my goodness, my computer. So 2, -4. So if I were to plot this, 2, -4 would be down here somewhere. So yes, it is in the solution region, and we've just proved it algebraically. If you have a careful graph, carefully sketched graph, you could probably see that right away. And that might be enough. It might be enough to say, yep, I'm confident that it is in the solution region. But also checking it using the algebra there is great too. So any questions on that example?